Today in Capechi's Corner, we're going to look at scatter plots and line of best fit. A scatter plot is a graph that we use to plot data. We try to figure out if there's a correlation between the paired data, which are the two variables. Sometimes we can notice that there's a trend. So in this first example, in this first graph, there's a negative correlation. As x increases, then y decreases. In the second example, there's no correlations. The points are kind of all over the place. And in the last example here, we have a positive correlation. As x increases, y also increases. Let's look at some more examples. In the first example A, we have some points that are plotted there. And when I do a line of best fit, I go kind of right in the center there. Now, a line of best fit is a line that most closely follows the trend of the data. I put the line kind of in between all the points. In letter A, we have a positive correlation. As x increases, y increases. In letter B, if I draw a line of best fit, again, I'm trying to go kind of right in the middle of all my data points, it looks like we have a negative correlation. So as x increases, y is decreasing. Now again, notice my line of best fit. It's called a line of best fit, not exact fit. So we're estimating every time we do a line, my line might be slightly different than the line that you would draw, but as long as we do the best we can, putting the line between all the data points, we'll be all set. And in part C, the data points are kind of all over the place, so there's no correlation in the graph for letter C. Now let's look at the graph that we're given. The first thing we're going to have to do is draw a line of best fit. So again, we'll just do our best to go kind of in between the data points. Try to do the best we can there. And the first question says, is a line of best fit positive or negative? And in this case, it's negative as x is increasing, y is decreasing. So that gives us a negative slope, which is a negative correlation. What is the approximate y-intercept? Now again, it might be slightly different. I did this problem in class and I got a different answer every time. This one looks like I'm close to 7. I did it one time I was a little lower, one time I was almost at 8. Some of my students got 8, some got 7.5, so it's okay. So the approximate y-intercept I'm going to say is about 7.5 in the one I just did. Now question 3 says, what is the best equation of the line of best fit for the scatter plot? So there's two things that I need to pay attention to. Again, my y-intercept we said is approximately 7.5. So if I look at my choices, in letter A, I do have a y-intercept of positive 8, so I'm going to leave that. That's pretty close to 7.5. B is also 8, and so I'm going to leave that one for now. In letter C, my y-intercept is 0, so I'm going to just cross that one up as an option. And the same thing with letter D. That also has a y-intercept of 0, so I'm going to cross that off. Now, in looking at narrowing it down now to A and B, I need to decide what is the same and what is different. So if I look at A and look at B, again, the y-intercept we said was the same. The difference is the slope. Now, we've already established that the slope is negative, so my best option in these choices is letter B. Let's look at our next example. It says the table gives the average class score Y on each chapter test for the first 6 chapters, which is X of the textbook. So our X values are the chapters and our Y values are the scores. Now the first thing I have to do is I plotted all the points in our little graph that they gave us. Now again, I'm going to have to do a line of best fit. So I'm going to somehow get in the center there, make sure I'm okay. Now I'm going to draw a line of best fit again somewhere in between my data points, make sure I'm okay. So it looks pretty good. Now I'm going to write an equation of the line using the line of best fit, and when I do that, I'm focusing on points that are on the line, not necessarily the table. So once I plot the points on the table, I am just finished with that information. So I'm going to use the points again. I'm estimating. So I'm going to use the point 284, and I'm also going to use the point 386. I'll use my slope formula to figure out what the slope is because I'm going to need my slope and my y-intercept. So it gives me 86 minus 84 over 3 minus 2, and in this case my slope was 2. Now again, it might be off a little bit. When I did this in class, one time my slope was 4 over 3, another time it was 3 over 2. So it just kind of depends on where your line of best fit is. Now I have my slope, which is 2. I don't have my y-intercept, so I'm going to have to use point slope. So I'm going to use this point right here. I'm going to use 284. So I have y minus 84 is equal to 2 times the quantity of x minus 2. So I have y minus 84 is equal to 2x minus 4. Add 84 to the other side, and I have 2x plus 80. Now the last thing that we see a lot that happens with the line of best fit is they want us to predict what's going to happen in the future. So let's do that now. So if I'm going to use my equation to predict the test score for the 9th test. So if I want to predict for the 9th test, first of all, the test itself is my x value in this case. So that's what I'm going to substitute 9 in. So I'm going to take y is equal to 2 times 9 plus 80, and I have y is equal to 18 plus 80. So when I'm predicting, I have y is going to equal 98, which is the test score that it looks like I'll get on the 9th test using the line of best fit. Now in our last example for today, we're given the graph, the data points are already plotted, and we already are given the line of best fit. So the first part says, part A, write an equation for the line of best fit. So again, I'm going to use points that are on my line, not necessarily my data points. So I'm going to use points that kind of go through the corner of my box. So I'm going to use that point right here, which looks like 432. And I'm also going to use 1020, which is right here. So my other point will be 1020. Now, similar to what I did in my last problem, I'm going to find the slope first. So the slope is equal to 20 minus 32 over 10 minus 4, which is equal to negative 12 over 6. So I have a slope of negative 2. Now that makes sense because my line is decreasing, so I do have a negative slope. I'm going to use my point slope formula. So I have y minus 32 is equal to my slope is negative 2 times x minus 4. So it gives me y minus 32 is equal to negative 2x plus 8. Add 32 to the other side. I have y is equal to negative 2x plus 40. Now again, my 40 is my y-intercept, and if I go back to my graph, that looks pretty good. And again, I also have a negative slope. So it looks like that equation is pretty good for my line of best fit. Now I'm going to use that prediction piece that we talked about earlier. So if I go back to the graph, I'm talking about price versus units sold. That's the heading for my graph right there. On my x-axis, I have the units sold in hundreds, and then I have price in dollars up on my y-axis. So if I'm asking to predict the price, if 1,800 units are sold, the units is my x value, and my price is my y value. So I'm going to solve for y. So I have y is equal to, I have negative 2, I'm going to multiply that by 1,800 plus 40. And with that, I get 4, which is really $4. So that's how much the price is going to be if 1,800 units are sold.